Kia ora boys, before we get started I just want to make sure you have your information pack with you, and in that information pack that you have got out your rock flowchart diagram and your igneous rock reference table. Once you have those two out in front of you, continue on with this video and fill them in. Hope you enjoy. Alright, in this video we're going to talk about igneous rocks, but before we can get into that we have to take a step back a little bit. Now we're going to be using our rock flowchart and we're going to be filling these out as we go. So let's get started. Now we're going to start with minerals. And of course minerals are the building blocks of rocks, and they are what make up rocks. And we're going to look at what happens when minerals combine in nature to form rocks. But here's the big question. There are so many kinds of rocks like this sandstone and granite and piece of obsidian and shale and pumice. All of these rocks exist in nature, of course, along with thousands of other varieties. And so the question arises, how do we classify them? Do we group them by their colour, their texture, their density? What do we do? Well, it turns out that the best way to classify rocks is based on how they form and the way in which this comes to be so. So let's add that to our sheets. Here, this bubble, under the word rocks, we're going to write that they are classified based on their method of formation, or simply how they form. And so if you do this classification, you will have three categories: igneous rocks, which we'll talk about today, sedimentary rocks, and metamorphic rocks. And so let's take a look at igneous rocks. What exactly is an igneous rock? An igneous rock is a rock that formed from cooling and solidification of magma or lava. Okay, let's add that. So they form from cooling and solidification of the lava or magma, and now that means that when molten rock cools down, it essentially turns into a solid. That is what igneous rock is. When you think of lava and magma, you probably picture the molten material in the crater of a volcano, and that's exactly what we're talking about. But what I want you to keep in mind is that there is a difference between lava and magma. When it is deep inside the earth, under the surface, we call it magma. Once it erupts onto the surface, we call it lava. Now this material, whether inside the earth or on the surface, can cool and solidify, and that gives us two different types of igneous rock. Igneous rocks are classified according to where exactly they did their cooling and solidifying, and so we have two types. Let's start with the first type. The first type of igneous rock is called an intrusive igneous rock. That means it formed inside the earth from magma. Now, as you can imagine, it's pretty hot inside the earth, and so the magma is going to cool very slowly. So magma cools slowly, and when it solidifies, it will allow minerals to form in crystals. But because it happens so slowly, those crystals are able to grow very large, and so intrusive rocks are always going to have a very large crystal. Let's look at this piece of granite. What you will notice is that it is speckled. All of those speckles are different mineral crystals. The black is biotite mica, the pink is potassium feldspar, and the whitest quartz. But the fact that you can actually see them with the naked eye tells me that they are big enough to have cooled slowly inside the earth, and that is an intrusive rock. If you want to know what I mean by big crystals, any crystals that are larger than 1 millimeter signify that the rock is intrusive. But of course, we can get really giant crystals. The crystals might actually be bigger than not just a millimeter, but actually a centimeter. So we're talking about very large crystals. So those are intrusive igneous rocks. But what about the second type? Well, as you might suspect, these are called extrusive igneous rocks. Instead of forming inside deep underground and cooling slowly from magma, these form on the surface because they cool really quickly from lava. You're going to get small or no crystals at all, and as a result they may even have air bubbles trapped inside, which is something we call vesicular. So again, extrusive rocks form on the surface very quickly, and so you get very small and maybe even no crystals, and they may have air bubbles trapped inside. Let's take a look at a rock called basalt, and you'll notice that you can't really see any crystals at all, even if you look with a magnifying glass. You might find really tiny ones, smaller than a millimeter, and that is a sign that this is an extrusive rock. And what about obsidian? It's cooled so quickly in a matter of seconds that no crystals were able to form at all, and so you get this kind of glassy appearance. Finally, if it cools quickly enough, you might get air bubbles trapped in the lava and become part of the rock, in the form of these vesicles or vesicular texture. So let's recap. A quick review. So, igneous rocks formed from the cooled and solidified magma or lava. When it cools slowly inside the Earth, we get intrusive, sometimes called platonic, igneous rocks, and they will have large crystals. When lava cools quickly at or near the surface, we will get extrusive rocks, also called volcanic, that will have small or no crystals. They may be vesicular, meaning that they have some trapped gas bubbles. There's a reference table which I have also provided you. This has the characteristics that will allow you to study them in more detail. Take a look at this table and see what you can learn from it.